The lines L1 and the line L2 intersect at B. We have to find that. Let's do this very quickly. The first thing that we have to do is write in the IJK format. So let's still maintain the column vector format. So 3 plus lambda 1. Then we have 1 plus minus lambda. That means 1 minus lambda. And then we have 2 plus 4 lambda. So this would be 2 plus 4 lambda. This is L1. And L2 would be R equals to 0 plus 1 mu. That means 0 plus mu. Then we have 4 minus mu. 4 minus mu. Then we have minus 2 plus 0 mu. That means minus 2 plus 0. That's all. So we have this. Now what we have to do is, if they're intersecting, the two vectors should be equal. That means comparing I, comparing j, comparing k, or simply we can just write these two column vectors equal. 3 plus lambda 1 minus lambda 2 plus 4 lambda equals to mu 4 minus mu and minus 2. So we have three equations here. So if I take the final one, 2 plus 4 lambda equals to minus 2, I can easily find the value of lambda. So lambda would be minus 4 divided by 4, which is minus 1. Now since we know the two lines intersect, there is no need to find the value of mu. We can simply put the value of lambda and find the point of intersection. So for lambda equals to minus 1, I'm putting it here in L1 because it has lambda. So we can write the position vector OB would be equals to 3 minus 1, that means 2, 1 minus minus 1, that is 2, 2 plus 4 into minus 1, that means minus 2. So we can write it in the IJK format, 2i plus 2j minus 2k, and the coordinates would be, therefore B has coordinates 2, 2 minus 2. In question number B, we have to find the angle between the two lines L1 and L2, and that's the dot product first of all. So cos theta equals to direction vector of L1 dot direction vector of L2 divided by modulus of the direction vector and modulus of the second direction vector. So that turns out to be, so 1 minus 1 4, that is the direction vector of L1, 1 minus 1 4 dot, I'm writing this as the column vector format. So direction vector is here with mu 1 minus 1 0, so 1 minus 1 0, and the modulus of this is 1 square plus minus 1 square plus 4 squared. Then square root of the second direction vector modulus is going to be square root of 1 square plus minus 1 square plus 0 squared. So now we can do the dot product, that is multiplying the coefficient of I with coefficient of I, coefficient of j with coefficient of j, and so on. So 1 into 1 is 1, plus minus 1 into minus 1 is 1, plus 4 into 0 is 0. And this is going to be square root of 1 square is 1, plus minus 1 square is also 1, plus 14 square is 16. So 16 plus 2 is 18. Square root of, this is going to be 1 square is 1, 1 plus 1 square is 2. So this is 2. So 1 plus 1 is 2 divided by square root of 18 into 2 is 36. This is going to be 2 by 6, which is 1 by 3. All we have to do is find the value of cos theta. Cos theta is 1 by 3. So the point A lies on L1. So if this is L1, this is L2. What we know, L1 and L2 intersect at the point B that has coordinates 2, 2, minus 2. We also know L1 and L2 makes an angle so that cos theta is 1 by 3. So this is the angle that we found, theta. Now we know that a point A lies on L1. So this is A, and it has position vector 3i plus j plus k. That means 3, 1, 2. And we have another one over here that has point C, and it lies on L2, and it has position vector 5i minus j minus 2k. So 5 minus 1 minus 2. So this is the information that we have. So we have to show that the modulus of the vector AB and the modulus of the vector BC, they are equal. So let's do this over here. Question number C. So AB vector equals to OB minus OA. Let me write down the column vector, it's quicker. So OB is 2, 2 minus OA. So OA is 3, 1, 2, and ultimately this is going to be 2 minus 3 is minus 1, 2 minus 1 is 1, minus 2 is minus 4, and the modulus of this is going to be square root of minus 1 squared plus 1 squared plus minus 4 squared. So this would turn out to be 1 plus 1 plus 16, square root of 18. And after that we have to find BC. So let's find, let me do it over here, BC. So BC is going to be OC minus OB. So OC is given, it is 5 minus 1 minus 2, and OB we already found, 2, 2 minus 2, and this turns out to be 5 minus 2 is 3, minus 1 minus 2 is minus 3, minus 2 minus minus 2 is 0. So modulus of BC would be square root of 3 squared plus minus 3 squared plus 0 squared. This would be 9 plus 9, 18. Therefore, AB modulus equals to BC modulus. Both are square root of 18. Question number D says, find the position vector of D. But what is D? The point D lies on ABC plane such that ABCD is a parallelogram. That means, so the D must be over here, somewhere over here, so that this turns out to be a parallelogram, ABCD, so that ABCD is a parallelogram. Now, in order to find that, we have to use the rule of the diagonals. That means the diagonal of this and the diagonal of these 2 points, they have the same midpoint. So we don't know what that midpoint is, but we can separately find the midpoint. So we can find the midpoint of AC and the midpoint of BD. Since they have the same midpoint, we can find the coordinates of D. So suppose the coordinates of D is X, Y, Z. So we can do this by, so question number D. So first of all, midpoint of AC. This is the midpoint of the vector AC. So let's find the coordinates. So it would be x1 plus x2, which is 3 plus 5 by 2, y1 plus y2, which is 1 minus 1. So this is going to be 1 minus 1 by 2, and 2 minus 2, which is going to be 2 minus 2 by 2. So the midpoint turns out to be 8 by 2 is 4, 0, 0. Now let's find the midpoint of BD. So the midpoint of BD, that is going to be, we don't know what D is, so this is X. So X plus 2 by 2, then Y plus 2 by 2, and Z plus minus 2 means Z minus 2 by 2. So we found both the midpoints, and we know for parallelogram the midpoints are the same. The diagonals meet at the same point, they bisect each other. So we can write the X equals to X. X plus 2 by 2 equals to 4. Therefore, X equals to 4 to the 8, minus 2 is 6, and Y plus 2 by 2 equals to 0. Therefore, Y equals to 2 into 0 is 0. So that becomes minus 2, and Z minus 2 by 2 equals to 0. Therefore, Z equals to 2 into 0 is 0. So minus 2 plus, this is going to be 2. So D has the coordinates of 6, minus 2, and 2. It's a good idea to always check with the answer format. So find the position vector. So we don't have to find the coordinates of D. We have to write down the position vector. Therefore, OD equals to 6i minus 2j plus 2k.